sorry for the delay. So my name is Nikos Kousias. I'm a PhD student at the Aristotle University of Thessaloniki, and I'm going to present to you my work with title Development of a Low-Cost Sensor for Particulate and Gaseous Pollutants. So first of all, why do we do that? Why do we need to monitor these pollutants? And the answer is that they reduce the quality of the air we breathe, and also some of them contribute to climate change. So it's vital to measure them and reduce them. Now, especially for particles, and especially for black carbon particles, the technology that exists is very good, and the estimates are very accurate, but they are also quite big and expensive. So there's currently a big race going on in the industry and academia to reduce the size and the cost of this technology. And you can see some instruments here on the top right of some first systems that are still in the 5,000 range regarding price. So there is further need for reduction. We also take part in this race, and for that we have chosen to use a sensor which uses the optoacoustic principle. Essentially, what you have is a laser source that is periodically turned on and off. Then you have an absorbing substance that can be a particle or a gas, and here it's depicted as a black spherical particle, which absorbs light, and it's periodically heated. And that periodic heating wave is translated into an acoustic wave that you can detect with a detector, ultrasound detector. Now, going on, what do we do to reduce the cost and the size, which, as I said, are the main goals? First, we replace an expensive high-energy light source that is typically used with a much cheaper laser diode. And of course, we try to optimize its operation by increasing the voltage and optimize its modulation. Then we also replace the traditional microphone with a quartz tuning fork, which is a very small and cheap component. And it's also very sensitive. Finally, we have an innovative design of our chamber, and instead of the traditional resonator, we use a geometry that tries to minimize the energy of the losses of acoustic energy. And with this, we want to achieve high sensitivity with low cost. As you can see on the top left, we have done some first experiments which have shown very good results compared to our reference instrument. Still, we have at least an order of magnitude to go down regarding sensitivity. So currently, we are working on that. We are working mainly on a lab scale environment, and we also have planned to test the system in current shipping applications, with the main goal to improve the sensitivity and prove that it can work in real-life conditions. In tandem, we have a modeling approach in order to better understand the phenomena and also to make easier the experimental work and the improvement of the system. Finally, for the final product, the applications that we imagine that it can be applied on is for sensor networks in cities that want to monitor the quality of the air, the real-time monitoring of vehicle emissions, which is very relevant for the car industry, and also emission monitoring at remote regions, especially the polar, which is a very hot topic for climate modelers and also for the shipping industry. Thank you for your attention.
Thank you, Nikolaos. Thank you very much for your presentation, and thank you for taking the right time for your presentation. So now it's time for the second pitcher, Ioannidis. Sorry. Philippos, are you ready?
Hi from Greece. Greetings. Can you hear me?
Yes, we can.
I can hear you as well, but I face some trouble with the sharing of my screen. I think that maybe I joined as an attendee, something like this. I don't know if Professor Varsakelis can share the presentation that I sent him, or maybe I just present it orally, because I don't have the option of sharing my screen, unfortunately.
Sorry,
can I just go on with
yeah,
presenting?
okay. Yeah, Perhaps it could be better if we can jump to the next one, and you can join to the last one. If there is no problem with the next one, is Maria. Maria, do you mind to do your presentation now?
Yes.
Okay. Yes. So Filippo, we will contact with you at the end. Okay.
Okay. Perfect. Thanks.
One moment.
Maria.
Just one moment.
Of course.
Yeah.
We can see now your screen, Maria.
Okay. Yeah. Okay.
Better.
Can you hear me?
Yeah.
Okay. Hello. Welcome, everybody. Let's start with my thesis speech about production of microbial oils to convert them into biofuels using vegetable waste and oleaginous yeast. I can. Okay. How can we help our planet without giving up our lifestyle and our needs? My name is Maria. I am a PhD student in the University of Alcalá, and I am doing my first year of my thesis in the Biofuels Unit in the Research Center for Energy, Environment and Technology in Madrid. And I would like to contribute to any ideas or solutions for this question. Well, nowadays there are several problems and needs that we could treat and improve with the research line, which I'm going to explain us today. Problems like air pollution, excess waste, depletion of resources, and needs like high energy demand, low countries transport, and commercial and heavy transport. Okay. In my thesis project called Acmibiome, we intend to generate microbial oils to later transform into biofuels using vegetable waste as low-cost raw material. So to achieve this goal, oleaginous yeasts are going to be employed. Why? Because these microorganisms have the ability to accumulate lipids, bio-oils, which are susceptible to be transformed into bioenergy such as biodiesel through well-known chemical reactions. Therefore, using fruit waste as carbon source and oleaginous yeast as producer of bio-oils, we could get a biotechnological process whose byproducts could be exploited in various sectors such as energy and transport sectors. But what are the benefits of this research? If we use our waste, a feedstock in a process, we are going to give a green output to this residue, in our case, vegetable waste, residual biomass. It is good to the environment and also to the industry due to the low-cost raw material. Besides, we would be recycling, reusing, and recovering elements, matter, and we will be contributing to a circular bioeconomy. On the other hand, the use of microorganisms, for instance, oleaginous yeast, is a pros too. With their employment, we will be obtaining interesting byproducts to transform them in bioenergy, like second generation biodiesel that is non-toxic and more eco-friendly than other fuels. Biodiesel which can be blended with diesel and which is compatible with carbon internal combustion engines. For these reasons and others, this bioprocess could be interesting and attractive to apply in a biorefinery. Finally, I would like to say that if we act now, many environmental problems will be reversible. However, if we keep waiting, probably there will not be turning back. Thank you.
Thank you, Maria. Thank you for your interesting presentation and for using the right time for that. So thank you very much, Maria. So now is the time for Daniel Santa Margarita. Daniel,
hello.
Are you ready?
Yeah. Okay. I will share you my screen.
Yeah, please.
I don't know if you see my screen now.
1 second. Yes, we can see your screen. Yeah,
Okay.
perfect, better. Thank
Okay.
you, Daniel. The floor is yours.
Okay, so my name is Daniel. I'm researching in the University of Alcalá, and I'm going to present you the importance of the research in power electronics for energy transmission improvement. Spain generates more or less 30 gigawatts of energy from renewable source. Part of this energy is losses in power conversion, transmission, and distribution. I'm an electronic engineer, so I'm focused on power converters and the improvement of those converters. If we only improve 1% the losses of these converters, we can charge 7,000 Tesla Model S every 3 hours in Spain only with the power of the renewable source, or charge 2 million of smartphones every 2 hours. So it is important to focus on the improvement of the efficiency of this power converter. But what are a power converter? A power converter is a system that can interconnect different systems like the solar panel and transform the energy obtained from the solar panel into energy that can be injected into the grid. And also the power converters can be used in order to interconnect different grids, like the DC catenary of the railway of Spain with the traditional AC grids, in order to make support between these grids or make some to feed some small charge near the catenary. My PhD focused on the improvement of these converters that connect the catenary with the traditional grid. The problem that these converters have now is that these converters are very heavy and bulky. They use a low frequency transformer, and the problem is that if we want to put this converter in the post of the catenary, the weight of the converter will break down the post. So we have to find a solution. The solution that we find is the use of a part of a solid-state transformer. This solid-state transformer use the electromagnetic inductance law in order to reduce the volume and the weight of the medium frequency of the transformer, increasing the frequency of the transformer from 50 Hz to 30 kHz. In that case, we increase the efficiency of the transformer more or less 1%. So, but we have some problem because, as can be seen in the left image, if we don't do a really good optimization of the system, the traditional solution, that is the REST solution, in some cases are better than the proposed solution with solid-state transformer. So we have to optimize very good the converter and the system. But what are the optimization parameters? There are a lot of optimization parameters with the primary topology, secondary topology, the medium frequency transformer, and the problem with these parameters is that these parameters are interrelated to each other. So there is a lot of parameters to optimize. I would like to show you how to optimize these parameters, but I don't have enough time to show you, and I would like you to understand something about the complexity of this system. So I will show you part of the complexity of this system through errors, because I think that this is the best way to understand something. I would like to show you with a real explosion, but we don't have enough money to do it in a real system, so I throw you through simulation. So if we are doing a medium frequency transformer that have the same power and the same voltage that a traditional transformer, we can say, okay, it's the same current, we can use the same wires. The problem with this medium frequency transformer is that if we use the same wire, we have something called the skin effect. This effect is that the current goes through the surface of the cable and the effective resistance of the cable is increased. So the transformer gets a very, very high temperature. And instead of, if we get a really good solution with a lead wire, we have insulation between strands, we don't have a skin effect, so we have a really good temperature at the transformer. Another important thing in this system is to use silicon carbide MOSFET, this is or silicon carbide transistor. This is a new topology, new technology of transistor, sorry. This technology has really good switching speed, but this is good because we can increase the efficiency, but this is bad because they are really affected by the parasitic inductance of the system. If we don't do a really good interconnection between modules, we can destroy the modules, but if we do a really good design with a low parasitic inductance, the module works okay. This is only a small approach about my PhD and all the research in solid-state transformer. So I let you some reference if you want to learn more about this topic and the wonderful world of power electronics. So thank you.
Thank you, Daniel, for your funny and nice, but very interesting and attractive presentation, Daniel. And now we are going to move to Estilianos. Estilianos, you mentioned that you don't have presentation. I am wrong?
It's fine now.
Okay, but do you want to present something or not?
Yes, I have a presentation.
Okay, so sorry for my mistake.
I was as attendee before, so I could not share my screen.
Okay.
Now it's everything fine. I hope you can see my
we can
screen.
see your presentation and we can hear you very well. So the floor is yours.
Thank you very much. I'm Stylianos Doulieris, a PhD candidate at Hellenic University of Thessaloniki, and I will present you my PhD research on the fuel consumption optimization of plug-in hybrid powertrains under real-world conditions. Let's see first the problem. European Commission targets to reduce CO2 emissions from the vehicle fleet by 2020 and onwards. We can see that the best performing cars currently are the plug-in hybrid vehicles that offer a high reduction potential of CO2. Furthermore, the high market penetration of PHEVs, there's an estimate that 30% of the fleet in 2050 will be plug-in hybrid vehicles. So that PHEVs are a big part of the solution for CO2 reduction. And what is the key parameter for achieving that low emissions we need to meet the targets is the optimization of the energy management strategy and the fuel consumption minimization of such powertrains. Now, what is the contribution of my PhD thesis? Initially, via experimental campaign, I'm trying to identify the operation of vehicles with electrified powertrains, especially with hybrid and plug-in hybrid vehicles. And based on observations from experimental tests, I'm building some simulation models in order to replicate the operation of such vehicles. Now, the aim is to use the simulation models in order to apply some optimization algorithms for the energy management strategy in order to reduce the fuel consumption. And this is achieved via the maximization of the efficiency of the internal combustion engine, the utilization of the electric energy stored in the high voltage battery, meaning that we have to decide whether to discharge or charge the battery and how to use the electric motor. And these are all combined for the not specific driving conditions, but real-world driving conditions in order to select the optimum operating point and achieve the fuel saving and the CO2 emission reduction. Now, what is the usage and the outlook of such a methodology? We can apply simulation-based development for this kind of vehicles. So such software can be used during powertrain design calibration. It is a generic approach, so it is applicable to a large sample of vehicles with hybrid powertrains. The methodology is targeted for real-world conditions to achieve CO2 reduction. And also, this tool can be used to estimate real-world fuel and energy consumption from new and modern plug-in hybrid cars. And with this, I would like to thank you for your attention.
Thank you very much, Estilianos, for your nice presentation and for your hard work. And now we are going to move to Sisimos Tomausatos. Are you here?
Yeah. Yes, I can hear you.
Yeah, perfect.
Can you see my screen?
Not yet.
Sick.
One second.
Now?
Yes, we can see your screen. So the floor is yours.
Hello, I'm Zismos. I'm a PhD student at Aristotle University of Thessaloniki and a member of Down to 10 project, which was developed and successfully completed under the Horizon 2020 framework. And our idea is to offer the opportunity to automotive industries, policymakers, and emission testing companies to enhance technologies for low emission and fuel efficiency passenger cars. Okay, let's face it. We all know the tremendous effects of pollutant emissions to our environment. Particle emissions from vehicles are one of the main contributors. Here you can see the evolution of particle emissions from the tailpipe to the roadside. In particular, particle emissions are responsible for chronic diseases and premature deaths across the EU. In fact, the smaller the emitted particle, the deeper the penetration into the lungs, as you can see in the ICRP respiratory deposition model. At this moment, particle number vehicular emission regulation is focused on 23 size or greater. For that reason, Down to 10 Consortium has developed an exhaust gas sampling system for accurate determination of particle emissions performance of the current and future vehicle technologies, such as plug-in hybrids. The main advantages of the Down to 10 system, which was developed in 3 stages, is able to measure particle emissions beyond emission regulation of 23 nanometer size down to 2.5 nanometers in a robust and a low-cost way. The system was tested and validated with various engine technologies such as natural gas vehicles and plug-in hybrids. The system is able to fit easily inside the vehicle, and the data revealed useful information about the particle emission performance of the future vehicle fleet, providing useful information in the automotive industry and policymakers. In particular, data revealed critical information about the emission performance beyond emission regulation under specific real driving events. After the successful completion of the Down to 10 project in the framework of Horizon 2020, and having in mind the stringent emission control in the near future, we are keen to further develop our understanding in future projects in the following directions: on-road emission testing with size threshold below 10 nanometer, renewable fuel effects, inputs to the development of fuel efficient and effective emission control, extension of methodology to other transport modes like aviation and shipping emissions, and offer a robust and low-cost way of PM sampling to vehicle manufacturers, regulation authorities, and emission testing companies. And with this, I would like to thank you for the presentation.
Thank you very much, Isimos, for your nice presentation. And now we are going to move on the next speaker is Lorena Peñacova. Lorena, I don't know if you are ready.
Yeah.
Okay.
I'm
Lorena.
ready.
Perfect.
Could you see the presentation?
Yes, we can see.
Like that. Yeah. Okay, I'm Lorena Peñacova Antona, and I'm doing my PhD thesis in an industrial PhD in the University of Alcalá. The topic is very innovative, and it's about the design and construction on electroactive wetlands type Medland. Let's start. The wastewater treatment is a big problem nowadays because a lot of population throw the water directly into the rivers. And for that, we need to treat all the water, not just the big cities. The small households is in the same. The three main problems is the high construction and operation cost in treatment plants, the slag production, and they need a lot of chemicals to treat the water. That is because we investigate and we find. Okay, we find the Medland concept that is related to the natural wetlands used in an industrial way to treat the water. We merge the microbial electrochemical technologies that are based in one kind of bacteria called electrogenic bacteria that is able to transfer electrons through the material, enhancing the removal of pollutants in the wastewater. With this merging these two concepts, we
are able to have a methane that have zero energy operation cost, no clogging problem, and no slots production. We are optimizing this treatment to be able to treat small houses and big industries like oil industry, paper, and others. First, we did a location study to try to find new places to put this technology. We do it in Vizcaya and Malaga, but we try as well in Mexico, Argentina, and Denmark to see how the climate affects our system. After we did a technical environmental study, Bison life cycle assessment and efficiency study, and we had very good results because we were able to treat the 90% of the input concentration, and more important even, the concentration of emerging pollutants that are a big problem nowadays because the hormones, for example, are changing the biodiversity and even plants and animals' behaviors. If we mix that, we were able to have a small treatment unit, 1 cubic meter. We have one in the Botanic Garden here in Alcalá. We had a middle one of 3 cubic meters, 5 cubic meters in a job center that with a laboratory and some other pollutants. And we had a 25 cubic meter one for treating the wastewater of a whole village of 200 inhabitants. Here we can see some photos. That's the aspect of our system with different surface. Here, for example, we have the isolated house for a normal family, that this house is not near any village, and this water was going directly to the lake, and now is totally treated and could be reused. And in other example, for example, the oil industry in the center and a whole village in the right. Therefore, we need to be aware of the key points of this presentation. That is that new technology is a natural-based solution, have a very low footprint, is very small, is compared to constructed wetlands, for example, could be adaptable to different conditions, like the climate of Denmark that is very cold to the climate of Mexico that is very warm. We don't have operation costs, now the slot production, and we are able to have like a garden because we could plant the surface of it. Thank you very much for your attention. I hope you like this new technology.
Thank you, Lorena. Thank you very much for your presentation and for the interesting thing that you mentioned in the presentation. And now, I don't know if finally Filipos has the possibility to share your screen and your presentation. Filipos?
Yes, hello. Hi again.
Hi.
We find a hybrid solution. Nikos, who is a colleague from Aristotle University, he's going to share the screen, and I'm going to just ask him to click on the next slide every time I want to, if it is fine with you. Okay. It's acceptable, no. Okay.
Of course, no problem.
Thank you. So if Nikos can hear us, maybe he could.
Yes, you should see it in a few seconds. It's loading.
Okay. Perfect. Now, can you see the screen?
Yes, we can. You can start.
So I can start. Thank you. So my name is Philippos Ioannidis. I'm a PhD candidate at Aristotle University of Thessaloniki. And today I'm going to present you part of my research titled Investing in Bridging Fuels, the Unit Commitment Problem of Public versus Private Ventures. So moving on to the next slide. Natural gas is broadly considered as the bridging fuel, the source that actually links the past and the future, the coal with the renewable energy sources. And if you prefer, or if you might, this is going to be the fuel that humanity is going to use for the next decades. So given the importance of natural gas, next slide. I take into my research, I zoom in into the specific case of Greece, and I explore the electricity market, and from the side of natural gas fired power plants. So in terms of electricity generation, as you can see, the natural gas is through the years is constantly growing, the share. And in 2019, it accounted for more than 40% of total electricity generation. So in our sample, we divide in public and private units, and we want to test which units are more efficient in terms of balancing cost and cash flows at risk. So next slide. This is the unit commitment problem that all CCGT units face globally, meaning that there is a difference between what they actually declare in the load declaration, then what the regulator imposes to the units to produce. These are the nominations, as we declare this in the middle, and then at the end we have a third column, which is the actual generation. So given those three different stages, if you prefer, we want to maximize and to see when the unit commitment problem is maximized. So moving on to this next slide. We used hourly data from the Greek electricity market, thousands of observations from 10 different production units. And the sources are from the Hellenic Energy Exchange, and they are really valuable sources. And this high frequent data led us to some specific results. Next, moving on to the next slide, Nikos, please. We divided our sample into 14 different scenarios in order to identify when the units are positive balanced, when they are neutral balanced, and when they have to pay balancing costs, and meaning that they are negative balanced. So moving on to the next slide. This is a graphical illustration of the different scenarios that we have created. With orange, you can see with orange color, you can see the revenues for the production units, and with purple, we have denoted the imbalances. The methodologies that we used are the well-known from the financial literature, RAROC, and the risk-weighted average methodologies. Next slide. These are some initial observations in terms of the findings, and as it is quite difficult to, detect what are the policy implications from this table. But in the next slide, I have aggregated our findings. Next slide, please, Nikos. Yes, here in this finding, it is obvious that there are a significant percentage of the units that are negative imbalance, and this crucially affects the profitability of the units. So next slide. This is again the empirical findings, and in the next one and the next slide, what is actually interesting is the difference between the imbalances that the average public units pay and what the average private units pay. So as you can see from this graph, the public units are way more efficient, and there is a statistical significant difference between the two categories. Next slide.
1 minute.
Yes, I'm concluding. This is also the graph of the cash flows that again shows how crucial it is to identify why it is important to focus on this part of the research. And in the next slide, the concluding slide, actually, I would like to focus on the next state of the research, which is our thought is to move on, and based on machine learning technologies, we would like to produce and construct a software that is based on the most recent available hourly data and would indicate optimal binding strategies for natural gas-fired power plants. Of course, this would lead to profit maximization for units, for natural gas fired power units. And of course, since this is going to lead to a reduction of the marginal system marginal price, this would lead also to social welfare. Our case study could easily be adopted to European and global states. So that was my side. Thank you for your patience.
Thank you, Philippos. Thank you very much for your interesting presentation. And now I think that this is the last presentation from the pitchers. So let me say, first of all, thank you for your presentations. So we have a difficult task now to choose the best one, because, to be honest, most of them are amazing. So thank you very much for your effort. And now, as I said at the beginning of this session, I would like to give the floor to Eugenia Leivadoura. Jenny, sorry if I don't pronounce well your name and surname. And she is from Hellenic Petroleum. It's a very important organization in Greece and in the world. And I would like to give the floor to Jenny. Jenny?
Hi, everyone, and thank you for making all these great presentations. It was actually very interesting. I can relate to most of them because I'm Jenny Livadaro, and I work in the Strategic Planning and New Activities Department at Hellenic Petroleum, and I'm an engineer for innovation and technology. So basically, what I do is research, and I have under my radar many researchers like you. So let me tell you a few things about what we do as an organization, our activities, and what we're looking for in terms of these new activities. I have some notes, so I'm going to read a few things. Please forgive me. I don't want to forget something. So we're a dynamic group. We have a leading position in the Greek energy sector and in the greater southeastern European area. Just to give you a number and understand, in 2019, we had a turnover of about 9 million. And we have a range of activities that includes supply, refining and trading of petroleum products, fuel marketing and retail, petrochemicals production and trading, oil and gas exploration, power generation and natural production, and provision of consulting services. Now, our core activity is refining, and it accounts for approximately 75% of our total assets. In Greece, we own 3 out of 4 refineries in the country, Aspropyrgos, Elefsina, and Thessaloniki. Just to give you a number, this is 65% of the Greek oil products and the total refining capacity of the country. Aspropyrgos produces approximately 150,000 barrels per day, and Elefsina and Thessaloniki approximately 100,000 barrels per day each. Now, we also have a terminal refinery in the Republic of North Macedonia. Then we go to fuel marketing and retail. Through our companies, ECO and the stations of BP that we acquired in 2009, we have a network of almost 2,000 fuel stations, which is a little bit more than 30% of the total Greek market. And we have some international activity with 300 stations in Cyprus, Bulgaria, Serbia, Montenegro, and North Macedonia. We have the only petrochemicals factory in Greece with a market share of 50%. We work as operators in international joint ventures for oil exploration. We have 9 sites and 1 more under negotiations. We are involved in the production, trading and supply of power in Greece by 50% in Elpedison. And we also have 35% of DEPA, which is a natural gas company in Greece. Now, one company of this that is closer to what I do is the Helper Renewables that works on production and trading of energy products produced by renewable energy sources. Now, Helper Renewables plans to develop significant wind, photovoltaic, and biomass capacity in the next few years, diversifying the group's energy portfolio and contributing to balancing its greenhouse gas emissions. What we have already, we have 7 solar parks with a total capacity of 20 megawatts and 7 megawatts out of a wind park in Messinia. And we have several projects in various stages of developments with a capacity of 200 megawatts of renewable energy from renewable energy sources. Finally, we have our engineering company, Asprofos, which basically provides a broad range of technical and project management services for our core activities. Now, the group is really engaged in the energy transition towards lower emission technologies. And there are several areas within the company that we are focusing on in this pattern. So we want to improve our core business. What can we do with our core activities? For example, digitalization and refining. We're working on it. We want to develop more core activities and utilize our investments. For example, we have great representation in the domestic market, but can we develop more our international activity? Then we want to develop new activities. This is where I am. The field of renewables, what can we do there? Hydrogen, biofuels, electric vehicles. This is all in the range of our exploration for new activities. And then safety and environmental standards. How can we adjust as fast as we can to new standards every time? So this is basically a broad area of what we do and what we want to do in the future. Now, about my role, so as an innovation engineer, what I do is I run all the R&D of the group. Whenever we want to explore a new technology, we make a research program, we have our research teams, we explore the option, we have a pilot site in our premises, and then we investigate whether we can scale this up and we can make it actually a business activity. So through my R&D, I have several research teams under my radar. Then my other activity is that I represent the group in innovation initiatives. So innovation contests, hackathons, everything that we support, I'm there. And what I do is that I have an idea of the innovation hub in Greece. So I know the startups that are related to energy technologies and potentially develop some form of collaboration in the future. So 5 things, whenever I want to start an R&D project, there are 5 things that I investigate. Relevance. How relevant is the project with our activities? Applicability. How applicable can it be? Third, scalability. How big can it go? Because, for example, in biofuels, we have a lot of research in biofuels, but what happens is that we have samples of 200 milliliters. If you're thinking of co-processing with crude oil in an actual industry, we need to scale up. Consortiums, who are our partners? Is this a long-lasting collaboration? Is their research something that interests us in the long run? And then involvement. There are some crucial activities in the refineries, for example, that we cannot touch. The pilot sites, the pilot ideas, the pilot research should not interfere with our crucial activities. So these are basically the criteria that we use in my group. And just to summarize, the areas of interest are technologies that reduce CO2 emissions, digitalization and refining, and technologies in refining in general, low greenhouse gas emissions fuels, second generation biofuels, synthetic fuels, everything that has to do with lowering the CO2 emissions. Energy storage, what happens with carbon capture and utilization, renewable energy sources, solar parks. What happens when we have excessive energy in the solar parks? Can we utilize it and do something else? Can we have a hydrogen plant, for example, that will use the excess of energy from the solar parks? And then electric vehicles. What can we do as retailers to engage with customers that will buy electric vehicles in the future? Thank you very much. I'm happy to take any questions from you guys.
Thank you, Jenny. So we have a couple of minutes to send some questions to Jenny, or in the other way. Jenny, you have any question from any pitcher? I think that it could be nice if you have any doubt or
Actually,
anyone from the audience.
So is Maria Gallego here?
Yeah, I think so. Maria?
Yeah.
Maria? Hello, Maria. Well, I say yes,
Hello.
and can you hear us? Yeah, Maria?
Yes, but I have problem with the audio occasionally.
Okay, no problem. Jenny has one question for you.
Just a question, comment. So in biofuels, what we're trying to do, we're trying to use some biomass and do some co-processing with crude oil. So far, internationally, we cannot exceed 3% to 5% of co-processing because of the exhaustion of the catalyst, because of the infrastructures of the refineries. Now, there are very few companies that try to have 100% biofuels, and they have done it only on experimental level. It would be interesting for your research and interesting to the industry if you could compare your biofuel with the European standards for biofuels in the retail market and see how far you are from that. Because in general, we produce biomass, but then the co-processing is very small and still doesn't reach the quality that is mandatory from the European standards. So just because you're in the middle of your research, maybe you could explore that too. I'm just saying this is a problem from the industrial side.
Yes, I am in my first year in the first step of in the laboratory scale, and there are several source or biomass to produce this biodiesel. And when we find the optimum condition and adequate media to generate the microbial oils and to transform them in adequate biodiesel, we will have to do a techno-economic study to know the viability, the cost, the application of the product in different sectors too, and the quality of the biodiesel and the competencies with other biodiesel, first generation biodiesel and other second generation biodiesel, for example, coming from oil of restaurant or at home, second generation biodiesel, and food crop to first generation biodiesel. But this is the next step. The first step is the laboratory scale yet.
Good luck, Maria.
Thank you. Thank you.
All right, let me see what else do I have here. Mr. Ioannidis with the natural gas research. Is he here?
Hi, yes.
Hi. So,
sorry.
you have an interesting approach in optimizing the natural gas units and measuring that. But I'm just saying that there's a growing market in solar farms in Greece. There will be a lot of optimization required with the excess of energy in the afternoons or the optimization of the produced energy there. So I'm just saying that natural gas is fine. It's here and will stay here, but this is a growing market. I'm just making a comment that maybe you could also explore that option as well.
Exactly. Given introduction of aggregators in the system, actually this is where the next decades where the efficiency part is going to take place, since renewables are going to grow their share in the market. The aggregators of renewables, both solar, wind, and also taking also advantage of hydro units, yes, that actually function as batteries. This would be of crucial importance for the market as well.
I believe in the Greek market, there is a new law coming about energy communities and how you can balance the green energy that you produce somewhere else with the energy that you consume in a different part of the country.
Yes.
So maybe you could work on that as well. Well, these were the main two activities that were very related to what I do, but please ask me whatever you want. Anyone?
These questions goes to all the attendees.
Yes, of course. Sorry, Philippos. Sorry.
Okay, so because
I didn't want to put you on the spot.
Any question to Jenny? No. Well,
the question.
Sorry.
May I have?
Yes, of course.
Yes. How many projects now do you run in your department?
Ooh. Okay, so when I first of all, I was for 6 years in the US and the UK working as a researcher. So I moved back a year ago. When I started the department, we had 5.5 research projects. Now we have 15. A full-time job, because I'm doing all the technical and the finance part. I need to break it down to different people now, but anyway, at the moment we have 15 projects. Most of them are on biofuels, CO2 capture. What else do I have? Let me see. One is on energy efficiency in buildings. Let me tell you. Yeah, many in biofuels. One is for sensors in the refinery to see any malfunctions. One is the PhD hub. I have one with building energy efficiency, some about catalysts. That's it, more or less. Mostly biofuels, but what I would like to have, what I'm looking for now, is something about, as I said before, the energy community. So how can you utilize the excess of energy from big photovoltaic parks? As you know, we bought a new solar park that has a capacity of 200 megawatts. That's huge. That's the biggest in this part of Europe. So we want to do what we want to know what we're going to do with the excess of energy from that park, because we will have lost energy eventually in the afternoon. We also want to explore the hydrogen plants in Europe and what we can do with hydrogen in Greece. And what else? And CO2 capture and utilization. This is something that is very expensive. It's an expensive technology. Whatever has reached me was too expensive and too risky. So I'm looking for new proposals.
Okay. Anything else?
Do you expect to make an expansion to automotive industry?
I doubt it. We need to expand to renewables. Let's try to do that first.
Well, I would like to ask you one question, Jenny, because you are well related to the research, and this is an event hosted by one European project related to PhD. So I would like to ask you about the added value that one PhD candidate
Don't ask me about my PhD.
No. I am asking you about
experience.
No. I am asking you about the added value that one PhD candidate can provide for a company like your company. What is this type of added value if you compare, for example, just with one student of a master's degree? So what is your opinion working with them?
Okay. now, speaking from my experience about when I was in my master's and when I was in my PhD, I think that I developed a more critical thinking and more critical writing during my PhD because I knew that it would go to different people and it will be discussed. So I was very careful with my writing. I think that during a PhD, you reform your thinking and you reform your writing. And whenever I get a document from it's significantly from a student on a master's level. Of course, I mean, I don't want to generalize, but I'm just saying that you've passed one level and you're working on a higher level of critical and careful writing. Now, the way that a student can reach us, I have to say it's difficult because we're doing strategy in the highest level in a very big company, and we don't make like experiments with our core activities. We're very careful with that. But well, they can reach me first of all via LinkedIn or Facebook. Everybody should have my name in the program, so you can reach. If they reach me, they should have either a research proposal in a mature stage, like with a consortium of people, and they should provide to a big company a full solution of something. They shouldn't expect from to work on the research. We are the end users, and we supervise the process, and we have a saying on the feasibility study at the end. We're doing strategy. We're not doing research.
Good.
We expect the research to be done from the research group that we work. And I mean, I see students through these research groups and the innovation festivals. So this was a good opportunity to speak with a few people from this group. Other company to festivals, to hackathons, to everything that Hellenic Petroleum supports.
Okay, thank you. Thank you very much, Jenny, for your explanation about the activity that you are doing in Hellenic Petroleum, and as well for asking to the pitchers these issues that perhaps they are not clear for you. And just one brief remark. In the closing ceremony on Wednesday, we will announce the winners of this session. Please, Jenny, send me by email your ranking with the 3 first positions. And for all the audience, just let me tell you that this session and this event is hosted by the PhD Hub project, and this project is more than this event. This project has a very nice platform where one of the goals of that platform is to connect researchers in the different stages, early research, middle research, senior researchers among Europe, discussing and working and talking about the specific research field that you are doing. So as you can check in this session, some of your pictures are very similar in terms of the specific research. So please use that platform to connect with another colleagues in this specific topic. So again, thank you very much for your time. Thank you very much for the participation, for the picture. Excellent work. Thank you very much, Jenny, for your time and your explanation. And this is the end of the session of today. Tomorrow we will start at 9. Let me check the agenda. 9 Central European time with another world field visit, in that case hosted by the municipality of Thessaloniki. Thank you very much and keep in touch. Bye-bye.
Thank you all. Bye-bye.
Bye.
Bye. Have a nice evening.